In this example, we'll solve a system of three linear equations with three variables. We'll use Cramer's rule. The equations are 3x plus 2y plus 2z is equal 0, x minus y plus z is equal 1, and x plus 3y plus 2z is equal negative 5. We'll start with computing the determinant of the system. This determinant is formed from the coefficients of x, y, and z. The first column are coefficients of x, and therefore the column is 3, 1, 1. The second column is form of coefficients of y, and therefore that column is 2, negative 1, and 3. And the third column are form of coefficients of z, so that column is 2, 1, and 2. We'll compute this determinant by expanding using the first row. So according to the definition, it is the first term in the first row, 3 times the determinant obtained by crossing out from this determinant the row and the column that 3 is in, and therefore we'll have the first row negative 1, 1, and the second row 3 and 2. Then we'll subtract the product of the second term in the first row multiplied by the determinant obtained by crossing out the row first and column 2. So the numbers are 1, 1, 1, and 2. And then we'll add the third entry in that row, which is 2, multiplied by the determinant obtained by removing the first row and the third column. And therefore the numbers are 1, minus 1, 1, and 3. Now we have 2 by 2 determinants, so we'll compute their values. It's 3 times. The first determinant is negative 2 minus 3. Then we'll have negative 2 times the second determinant, which will be 2 minus 1. And then we'll have plus 2, and the third determinant is going to be 3 plus 1. Value of that expression is negative 9. So the main determinant is different than 0, and therefore, according to Cramer's rule, the system has exactly one solution. To find it, we need to find the determinants dx, dy, and dz. So determinant dx is obtained from the main determinant by replacing column of x coefficients by the numbers on the right-hand side. So the 0, 1, and negative 5 go into the first column, and the second column and the third column are unchanged. And we'll compute this determinant. Again, we'll use the first row. So it's 0 times the determinant consisting of numbers negative 1, 1, and 3, and 2. Then we'll subtract the second entry in that row, which is 2, and we'll use determinant 1, 1, negative 5, 2. And then we'll add to that the product of the third entry in the first row times the determinant obtained by crossing out the first row and the third column, which will be 1, negative 5, and 3. And we'll compute that value. So the first term is 0, then we'll have negative 2, and the second determinant is 2 plus 5. Then we'll have plus 2, and the third determinant is going to be 3 minus 5, and that value is negative 18. Now we'll compute determinant d sub y by replacing the column of coefficient y, and therefore the second column, with the column of numbers from the right-hand side. So it's 0, 1, negative 5. And the column of coefficients of z will remain in place. And if we compute that determinant, we'll get the value 9. Now we'll compute determinant dz. This determinant is obtained by replacing in the main determinant the column of coefficients of z with the column of numbers from the right-hand side. So the first two columns remain the same, and the third column is replaced by 0, 1, negative 5. And the value of that coefficient is 18. Once we have all four determinants, we are ready to write the solution. X is dx over d. So this is negative 18 over negative 9, and that value is 2. The y is d sub y over d, and dy is 9, and the d is negative 9, so y is negative 1. And z is dz over d, which is 18 over negative 9, and therefore that value is negative 2. And therefore we can say that the solution of that system is the triple of numbers x is equal to, y is equal negative 1, and z is equal negative 2.